Hello everyone. So let's now solve practice assignment week 7 question number 2. Let denote the standard inner product on R3. That is, we are defining a standard inner product as our function and consider linear transformation from R3 to R defined as T of U, which is where U is any vector in R3, is defined as a dot product with U and V, where V is some vector in R3, which of the following options are true. So now we have to check whether T is 1 to 1 or on to and isomorphism. So for one-to-one, it's easy to check that we have a transformation from R3 to R, and we can see that the dimension of domain is greater than the dimension of codomain. So T can never be one-to-one, and the way to prove it is, let's say suppose T is one-to-one, then this means that nullity of T should be equal to 0, and by rank nullity theorem we know rank of T plus nullity of T should be equal to dimension of domain, that is 3, and we are supposing that the T is 1 to 1, that means the nullity would be 0, so we will get rank to be 3. But this case cannot happen as the dimension of codomain is 1, and we know that the rank is the dimension of the range space of our transformation, and range is a subset of codomain. So this cannot happen. That means our supposition that T is 1 to 1 is wrong. So T can never be 1 to 1 here. So that means the third option is true, that T is not 1 to 1 for every V belonging to R3. This is not only just for that V not equal to 0, it is true for any case here. Now we have to check for 1 to 1. So let's say if our V is equal to 0, if V is equal to 0, that means our T of U is defined as the dot product between U and V, and if V is a 0 vector, that means for any U we will get this value to be equal to 0, because dot product with a 0 vector will always give us as 0. So that means our transformation would literally be like T of some xyz is equal to 0 comma 0 comma 0. It would be like this. Oh, sorry, uh, just 0. So in that case, the rank would be 0, uh, as nullity would be 1 and rank would be 0. So T will not be 1 to 1. But if our V is not equal to 0, now if V is not equal to 0, then T of U is dot product with U and V, and as we know V is not equal to 0, that means we will get some real number here. So our rank in that case, that is the range space, would be some real number, and the dimension of range space would be 1. So as that is also our dimension of codomain, so our T would become onto in that case. So only when V is not equal to 0, it would be onto. Otherwise, if V is 0, then any vector in R3 will only map to the 0 vector. So our transformation will not be onto in that case. So only when V is not equal to 0, it would be onto. So this option is correct. And as it is not 1 to 1, so it will not be isomorphism. And this is also wrong. Thank you.